Hello guys, welcome on Tesla Adventures. In this video, we are going to find out the magnetic field due to this arc on the axis of the arc, but not at center. At center we have already discussed the formula, but now we have to find out the magnetic field on the axis. So first of all, we know that the net magnetic field on the axis due to a small element, let us suppose that this is a small element, okay, so this is dl, and the net magnetic field due to this element will be like that, perpendicular to this r vector. This is r vector. You could imagine that this is a three-dimensional diagram. In this there is a arc, and this is the center of the arc, and this is the axis of the arc. There is a point P on the axis on which we have to find out the magnetic field, and at this point P we know that the magnetic field direction dB due to a small current carrying arc will be in this direction. So if this angle is phi, let us suppose that this is phi, and if we draw this line like that, yeah, okay, so if this is phi, then this is 90 minus phi, and this is phi. So the component of dB in this will be dB cos phi, and this will be dB sin phi. And now dB cos phi will not be cancelled out, and therefore there will be both components of magnetic field which are non-zero, and we have to find out both the components. So first of all, let us talk about the dB cos phi, and let us name that integration of dB cos phi is b perpendicular, and integration of dB sin phi is b parallel. So first of all, let us talk about, or we can find out dB first of all. So dB will be again mu naught I by 4 pi r square dl and sin 90. So sin 90 will be 1 because the angle between dl and r is again the same, which is 90. So dB will be equal to mu naught I dl upon 4 pi r square. This is dB. And now if we simultaneously integrate both the sides, so first of all let us use a page. So if we simultaneously integrate b perpendicular and b parallel, so b perpendicular will be integration of dB cos phi, and b parallel would be the integration of dB sin phi. And dB is obviously mu naught I dl by 4 pi r square. So this is mu naught I dl upon 4 pi r square, and cos phi will be x upon r. So it would be x upon r, and b parallel will be equal to integration of mu naught I dl upon 4 pi r square, and sin phi will be this is capital R upon small r. So this is capital R upon a small r. Okay, so b perpendicular will be mu naught I x upon 4 pi r square integration of dl, and b parallel will be integration of, or this is mu naught I r upon 4 pi r cube, or and this will be r cube. Okay, and integration of dl. Okay, limit of dl will be from 0 to L, where L of the arc, length of the arc will be equal to r alpha. Okay, so length of the arc L is R alpha, so limit will be 0 to R alpha. So 0 to R alpha. So now, so B perpendicular will be equal to mu naught I x R alpha upon 4 pi R cube, and B parallel will be equal to mu naught I R square alpha by 4 pi R cube. Okay, now you can see that this formula is resembling to the previous formula which we have created, which was mu naught I R square by 4 pi R cube. You can substitute the value of alpha as 2 pi. So this will be the exact same formula which we have created initially. So it would be B parallel will be mu naught I R square into alpha divided by 4 pi R square. R, small r, can be written as R square plus x square to the power 3 by 2. So if we substitute the value of alpha for the complete ring as 2 pi, then cancelling this 2 pi with 4 pi, there will be a remaining 2 in the denominator. So the formula will be mu naught I R square by 2 R square plus x square to the power 3 by 2. And B perpendicular will be mu naught I x R alpha divided by 4 pi x square plus R square to the power 3 by 2. So this is the final result, and we know that if this ring is not a complete ring, then there will be two components of magnetic field, which will be, one of them will be perpendicular to the axis of the ring and the other one will be parallel to the axis of the ring. And if in any question it is being asked that there is a arc whose angle is, let us create one question, that in any question it is asked that there is a arc whose angle subtended at the center is pi by 6 or pi by 3, and we have to find out the magnetic field at a point which is on the axis of the arc at a distance of x, and we just have to find out B parallel. We do not bother about B perpendicular. If B perpendicular is asked, then we have to remember this formula, but if B parallel is asked, we should not remember this formula. What should we do? We remember the formula for the complete ring, so we would use that analogy. We know that for complete ring on axis, B was mu naught by 2 mu naught I R square by 2 R square plus x square to the power 3 by 2. But by using the unitary method, we can find out B parallel due to arc. B parallel due to arc will be mu naught I R square by 2 R square plus x square to the power 3 by 2, and this is for the complete ring, so we should divide it by 2 pi because the angle formed by the complete ring is 2 pi on the center, and the arc is making an angle of pi by 3, so it would be pi by 3. So B will be mu naught I R square by, this is 12 R square plus x square to the power 3 by 2. This is B parallel due to arc. Okay, so this is the direct method to find out only B parallel due to arc on its axis. Thank you.